Hello everybody, thanks for having us here. I'm going to talk about machine translation and in particular about something that is close to my heart about how we should actually think about machine translation and how should we see it as a changing field. I will start with a landscape of what the machine translation community was concerned with in the last 10 years or so. And most of these acronyms or names, I'm pretty sure that most of you are familiar with, is about statistical-based machine translation, BLE in terms of measuring how good the translations are, technology, if it's phrase-based, syntax-based, synchronous grammars, and other things that are emerging in the last years, such as domain adaptation, or quality estimation, or parallel data identification. So all these things are things that you can see in the research community that talks about machine translation. And when you look at the industry and what industry is concerned with regarding machine translation, you can see discussions about statistical versus rule-based versus hybrid, how do we leverage TM repositories, how do we do customization, how do we build machine translation apps, use cases. So all these things pop up very often when machine translation comes into discussion. But when you look at what matters in the end to the customers and to the end users, it turns out they don't care about the technology behind machine translation, whether it's rule-based or statistical or hybrid. They certainly don't care how you measure it and how BLE is computed. They don't care about incremental advances or about data. They basically care about what can they do with the MT and how you can have value out of it. It turns out that our philosophy is that a lot more value can be created when you plug the MT solution inside your ecosystem in an enterprise. And for that, we have identified these wheels that can turn the value of machine translation into something that can really make an impact. And these wheels are basically about the TM assets that you can have. They are about customization and they are about user feedback. And even better is when you can bring the web into the equation and when you can leverage the existence of huge repositories of data that are available on the web. Before I move on, I will make a short tour into showing you a bit of how statistical machine translation can be seen from a very high level in terms of what matters for statistical machine translation to work. And on the y-axis there you have empty quality. It doesn't matter how you measure it, it's just higher is better. And the truth of the matter is that the amount of data that you use matters a lot. So more data equals more quality. It seems to be sort of a logarithmic scale, but still you still get a lot of advantage out of having more data. And this is one of the reasons, for instance, that everybody talks about Google Translate, because they were the first ones to crack this big nut of how do you leverage large amounts of data. The other part of the equation is, of course, better algorithms, and this is what mostly is being discussed in the academic community. How do we do better in terms of models, in terms of algorithms? There is another important dimension there that is domain-specific. Basically, if you focus your data on a specific vertical, on a specific domain, then you can get a lot more quality out of that. And finally, there is feedback, the usage that you get out of let's say, initial rounds, that if you can have a positive feedback loop there, then you can definitely increase the quality. So that these four dimensions being given, the question that I want to ask here, and then I'll take a few steps to answer it, is what you get with MT when it's part of a larger ecosystem. And the first thing that you get is basically the TM asset exploitation. And again, I'll refer to Google as being the prototypical example here, because when you have data that is being hidden inside billions of web pages, you need a very strong infrastructure, very strong engineering support and expertise in order to be able to mine that data out. But once you can handle the amount of data at the web level, and once you have the algorithms in place to identify parallel data, then you can basically start milking this huge resource in terms of parallel corpora for building very powerful machine translation engines. What I'm getting at here is that basically there were lots of evaluations done that are showing that indeed, however you want to measure it, and this is on a scale of 1 to 5 in terms of evaluators liking the translations, you can see clearly increases as you add more data, let's say from 1 year to the next. When we started exploiting this, the availability of data mined from the web, you can clearly see increases. So the point here is that it doesn't really matter at one specific point how good your engine is. If you're part of a large ecosystem where exploiting data comes naturally by having the infrastructure in place, then this curve will, this performance will continually increase by the sheer fact of adding lots of data according to the equation that I described before. So this is the TM asset exploitation in terms of milking this hugely important asset of data, which is the web, is a very important part of what you can do with machine translation inside this larger ecosystem that allows you to do this exploitation. Another important part there is the adaptation, in which you can basically have all the parallel data available to you being combined with signal that comes from the enterprise needs or usage. And once you can successfully combine this signal, you can extract training data via some data selection method that in the end will give additional advantage. And I have another pair of comparisons here that basically show across languages the fact that you can get huge gains in terms of accuracy of machine translation simply by using less data, but more targeted towards the domain that the customer is interested in, that particular vertical. And a third point that I want to bring is about how we discovered as an extremely important facet of empty adoption the fact that you can make your empty system or empty ecosystem, so to speak, auto-aware of its own failures. And this is a piece of technology that we call TrustScore. You have here an example of English Korean for a specific customer where basically on this scale of 1 to 5, you can have the automatic prediction correlate extremely well with the human prediction in terms of how good the translations are on this scale of 1 to 5. And you can see that when the humans are saying it's good, the machine also tends to say it's good, and the other way around. So we call this auto-awareness because it's, in the end, part of this, it's not the empty engine itself, it's a layer on top of the empty engine that does that. But once you have that in place, that opens up the possibility of integrating your empty solution into applications that are now taking advantage of this being available to them. And be aware that in case of empty failure, when it's recognized that probably the poor job, then you can have alternative ways of dealing with it. And the last part of this ecosystem is basically the integration of user feedback. We have this product that we call BGlobal that allows one to handle these terms and phrases. You can add them to so-called dictionaries. They will improve translation instantly on the phrases that you're targeting. We also have feedback and suggestion widgets that can be used there to basically rate translations so that you can improve on the prediction capability. You can also suggest different translations that can be used to improve the empty engine. So all these things we believe are very, very important for a solution that has empty at its core to be successful, because only integrating these wheels together you can fully leverage everything that has been done up to date in the machine translation field. For the future of MT, I've tried here to identify a couple of the challenges that we see ahead. One of the challenges it turns out to be how do you scale from basically hundreds of customers to, say, tens of thousands of customers that each have their unique characteristics and requirements. We would like to be able to do that, to basically adapt the MT solution for each of these individual customers, but this is still a challenge that it's somewhere in the future to be solved. Adaptation is again something that we currently do, but it's also something that is clearly things need to be done even better, so that you can very quickly and efficiently adapt to say changing in terminology and the style. So all those things are important for the adoption of MT future in this ever-changing world, but it's the current technology basically does it at a too slow of a pace according to most of the customers and to how we feel about this. So this is again another challenge of how you do quick adaptation. And then finally, feedback. I presented a couple of ways in which we currently incorporate feedback into the MT engines, but doing automatically some sort of automatic adaptation based on this feedback inside of an MT ecosystem is still something of a challenge, and is a direction that we would love to see people look into and contribute to bring clever solutions. So I would like to end with basically asking you to take a step back and change a bit the perspective on MT that you may have currently, in which the technology components are maybe not so important. What is important is the ecosystem and the value that you can bring with the entire ecosystem to the end customer, and that's where they will see the value coming most. Thank you.